All right, let's dive right in. We're going deep into the ocean today, but we're not looking for lost cities or mysterious creatures. Nope, we're on the hunt for something you can't even see, but that is changing everything. Data. We're going to explore how mashing up information from satellites, sensors, and ships is giving us a completely revolutionary way of seeing our seas.
So, here's the central puzzle for today, and it's a good one. How can the very same pieces of information help a local fisher find their next big catch, and at the same time help an international agency track down criminals on the high seas? It sounds kind of impossible, right? Well, stick with me, because that's exactly what we're going to unpack.
And here's our roadmap. We're going to start with the big idea behind it all. Then we'll look at it from 4 totally different perspectives: the fishers, the scientists, the policymakers, and the enforcers. And finally, we'll pull it all together to see the incredible big picture.
Okay, so first stop, the core concept that makes all of this work. We're talking about a genuine revolution in how we understand the ocean. And believe me, it's way more than just looking at a fancy new map.
The real secret sauce here is a concept called data fusion. Just think about it. You take satellite images of the ocean's surface, you layer on temperature readings from buoys, you add in decades of fishing records, and top it off with real-time ship tracking. Instead of having a dozen different confusing pictures, you fuse them into one single, crystal-clear view of what's happening out there. This idea, well, it's the engine for everything else we're about to talk about.
So let's see this thing in action. We'll start with our first group, the folks out on the water, the fishers. For them, this isn't some abstract science project. This is about their livelihood. It's about finding fish faster, burning less fuel, and making a living.
So, what kind of data does a fisher need? Well, they need to know where the fish are going to be. This is a perfect example of data fusion. They can pull down satellite data on sea surface temperature and chlorophyll levels, which is basically a signpost for fish food. Then they mash that up with historical records of where people have had good catches before, and layer on what we know about fish migration.
And here's where the big leap happens. The old way, you just look at a map of ocean temperatures and guess. But now, by fusing all that data and running it through an AI model, you can create a predictive heat map. We're talking a literal fish forecast that points you to the spots with the highest probability of a great catch. That's an absolute game changer.
All right, next up, let's shift gears from the economics of fishing to the world of pure discovery. Marine scientists are using this exact same data, but they're asking much bigger, more complex questions about the fundamental health of our oceans. You see, for a scientist, it's not about the next catch. It's about the next decade. They need to understand what's happening over the long haul to build conservation plans that are based on solid evidence, not just educated guesses. And to do that, they bring out the heavy hitters. They use correlation models to see how a plankton bloom today might affect fish populations 6 months from now. They use clustering models to automatically identify distinct ecosystems from space. They even use computer vision to identify fish species from underwater photos, which saves literally thousands of hours of painstaking manual work. It's a huge leap in what they're able to analyze. Okay, let's zoom out one more time. We've gone from the fishing boat to the research lab, and now we're headed to the government building. Policymakers have the incredibly tough job of managing this massive shared resource for everyone, trying to balance economic needs with the long-term health of the ocean.
To do their job, they rely on key metrics, and this is one of the big ones: catch per unit effort, or CPUE. It's a really simple but powerful idea. It boils down to one question: are we having to work harder and harder just to catch the same amount of fish? If that number starts to drop, it's a giant red flag that a fish population might be in serious trouble.
And once again, you see this incredible shift from being reactive to being proactive. In the past, all a policymaker could do was look at past trends and try to fix a problem after it happened. Now, with predictive AI, it's like they have a crystal ball. They can run simulations and ask, okay, if we put this new fishing limit in place, what will the fish population look like in 5 years? And get a real, data-driven answer before they make the final call.
And that brings us to our final group, and honestly, the most action-packed part of this whole story: the enforcers. We're talking about the coast guards and agencies whose job it is to police the unbelievably vast open ocean.
So what's their number one headache? It's something called IUU fishing. That's illegal, unreported, and unregulated. A lot of this is done by what's known as the dark fleet. These are vessels that just switch off their tracking systems, their transponders, to effectively become invisible. It lets them sneak into protected areas or hide what they've caught.
So how in the world do you find a ghost ship? Well, one of the coolest tools is anomaly detection.
You basically train an AI on billions of data points of what normal ship behavior looks like. It learns the difference between a ship that's just passing through and one that's actively fishing. So the moment a vessel starts doing something weird, like hanging around a marine sanctuary for no good reason, the system automatically throws up a red flag.
But what about the ships that are completely dark? The ones with no signal at all? This is where data fusion becomes a legitimate superpower. There's a type of satellite called synthetic aperture radar, or SAR, that can physically see a metal ship on the water, day or night, through clouds, it doesn't matter. The system sees that blip from the SAR satellite and instantly checks, is there a tracking signal coming from that exact spot? If the answer is no, bingo, you've found a dark vessel. An alert goes out to the enforcers automatically. Potential illegal vessel at these coordinates, go check it out.
Okay, so let's tie all of this together. We've seen how this technology serves a fisher trying to make a living, a scientist trying to make a discovery, a policymaker trying to ensure sustainability, and an enforcer trying to uphold the law, all with very, very different missions.
But the common thread here is incredibly powerful. It's not just that they're all using data, it's that they're all pulling from the same unified well of information. What one person uses for economic gain, another uses for scientific discovery, another for sustainability, and another for security. It creates this one shared digital view of the entire ocean.
And that right there is the answer to the riddle we started with. The power isn't in any one piece of data, it's in the integration. It's in weaving all those different threads together to create a single tapestry that's way more powerful and valuable than any of its individual parts. That's how you can find fish and fight crime with the exact same system.
What this technology really does is push us away from thinking in silos. You start to see how it's all connected. A fisher's catch is directly linked to a scientist's research, which helps inform a nation's policy, which is then backed up by an enforcer's mission. It's all one huge, interconnected ecosystem of information.
And that leaves us with one last big thought. For pretty much the first time in human history, we have the tools to see and understand our oceans with this kind of unbelievable clarity. The technology is giving us the eyesight. The question that's left for all of us is, now that we can see it all so clearly, what are we going to choose to do?